have this handout. I placed that in Canvas, and I place another one that you should have handy when we move into techniques of integration. Okay, so this is what we this is where we stopped last class. Okay, we said that the definitive integral, which is the integral from a to b of f of x dx, was equal to f of b minus f of a, where big F is the antiderivative of a small f. Meaning, when we take the derivative of big F, we should get the small one, right? All right, so today, what we're going to start learning is ways to get big F, the antiderivative, okay? And then we will come back to the definitive integral. So for that, I'm gonna use this handout. It's kind of blurry, what's going on? There. So the first example we're gonna do is the one there, okay? So this is how it's gonna work. All right, I'm gonna rewrite it here. I'm gonna use this paper. All right, so it says the following. Let me see who's here and who's not. Tambi's in the house, Gabriel, Adnan, Vanethi, Julie. Let me see your faces at least for a little bit, everybody. Iman, Kamsi, Julie, Julia Bechara, Danny, Vanethi. Fix your hair, wash your face, let me see it. And that goes for Julie, for Ed, for everybody. All right. For Adnan. Edward, you listening?
Yes.
Let me see your face, Mr. Alice. I know you're there. Thank you, Adnan. Thank you, Vanethi. All right. Edward, Alan Paul. All right. And everybody. All right, cool. All right, so let's see. So we're going to start with the first problem, which is dy dx is equals to 3x squared minus 8x plus 5, right? It says that is the gradient, which means this represents the slope at any point. So if we wanted to find the slope at 5, then we just plug in 5 into this, into x. If we wanted to find the slope at 3, we plug in 3, all right? And it says that this is the gradient of a curve, and the curve passes through this point, 1, -4. All right? Find the equation of the curve. All right, so we're gonna do that. The idea here is to solve this equation, okay? This is called a differential equation. And the reason for that is because there is a derivative, and we have that derivative equal to an expression. So that's called a differential equation. And this is, the point is really a condition for that differential equation, okay? So how do we solve this? Well, we're gonna solve it by finding the antiderivative, which implies we have to integrate. So to solve this, you're gonna write dy is equal to 3x squared minus 8x plus 5. All that times dx, all right? So basically we're separating the variables. Y in one side of the equal sign, x on the other one. And from here, we're going to integrate. So we're gonna find the integral or the antiderivative of y, and we're gonna find the antiderivative of all this expression. the antiderivative of y is what we're looking for, which means that's just y, okay? The antiderivative of dy is y. And here, well, we need to solve that integral of this antiderivative. Oh, sorry, this is negative, not, it's negative 8x plus 5, all right? So how we're gonna anti-differentiate this? One thing we're gonna learn in this problem is that we are able or allowed to split this up into 3 small integrals or 3 antiderivatives, okay? You don't have to do that every time. I'm gonna do it for the purpose of explaining, okay? But in reality, we can think of this as 3 separate antiderivatives. Okay? And then we just solve each one of them. What's the antiderivative of 3x squared? What should we differentiate to get 3x squared? 3x squared.
X cubed.
Which one?
X cubed.
X cubed. So the derivative of x cubed is 3x squared. 3x squared. All right? Minus. So here, I'm going to apply 2 properties. I want you to pay attention to that. One of the properties that we can take 8, which is a constant, outside the integral. Okay? And then once I take 8 outside the integral, inside I only have this. Okay? So what's the antiderivative of x? What should I differentiate to get x?
X squared.
If you differentiate x squared, you get 2x, but you just need x.
1/2 x squared.
Right, so the antiderivative of this is 1/2 x squared. So that's what I need here. Okay? Plus, what's the antiderivative of 5? I can think
5x.
It's gonna be 5x, correct. It's gonna be 5x. So plus 5x. Now, since there is a condition, that means that there is a constant that I need to add at the end. We don't know that constant yet, but we're gonna use that condition to find what that constant is. So up to now, y will be x cubed, 8 times 1/2 is negative 4 x squared plus 5x plus c. Up to there. Now we're going to use the condition. So what does the condition says? That when I plug in 1 for x, I should get negative 4. So from here, I'm going to say negative 4 is equal to 1 cubed minus 4 times 1 squared plus 5 times 1 plus c. And from there, I'm going to solve for c. So this is because I'm using the condition, all right? The point that was given to me. So from there, we're going to have what? Negative 4 is equal to 1 minus 4 plus 5 plus c. So how much is c then? Five plus 1 is 6, minus 4
-6.
will be -6. So y is then equal to x cubed minus 4x squared plus 5x minus 6. And that is the curve that satisfies this differential equation, okay, given this condition. All right. Any question? No? All right. If there are no questions, then we're going to do some of the practice problems. Okay. I already placed the homework in Canvas from these notes. So let's start with 1B. I'm going to do 1B. Okay. So 1BI. So 1bi says that we have the derivative with respect to x of a curve, which is equal to 1 over the square root of x. Okay? And that the curve passes through 4,8. So we need to find that curve. All right. So same process as before. Separate the variables. dy is going to be equal to 1 over the square root of x times dx. And once you do that, then we integrate on both sides. The antiderivative of dy is y. And this, we're going to leave it like that for now. Right? So this is what I need to solve now. I need to find that antiderivative. All right, so I want you to think of 1 over the square root of x as x to the 1/2 dx. Okay? Now, for those of you that told me that this...
Wait, isn't it next x to the negative 1/2? Or?
Actually, yes, you're right. Negative 1/2. Thank you. Because it's in the bottom. Right. So, what did we do here in order to find the antiderivative of x? What was done? Can anybody tell me like a general rule? What was done to go from the integral of x to 1/2 x squared?
You take out the coefficient.
Okay, that was one piece. What else did we do? Focus on the integration piece. What was done to x, or what can we do to x to make it 1/2 x squared?
We raised the power of x.
We added 1 to the power of x, and what did we do afterwards? We divided by that power, right? So look, when we have the integral of x to the n, x to a power, the rule to anti-differentiate that is x to the n plus 1 is a power rule. You add 1 to the exponent, and then you divide by that exponent. And in this case, we need to add a c. So this is the power rule for integration. Okay? That rule. So here, we're going to apply that rule to find y. So the integral of x to the negative 1/2 will be x to the 1/2, because it will be negative 1 plus 1, right? Divided by 1/2 plus c, which is equivalent to 2 times x to the 1/2 plus c. Questions so far? All right. If you don't have a question, then now we're going to use the condition. So then now 8, which is the y value, should be equal to 2 times 4 to the 1/2 plus c. So then we have a square root of 4, that's 2, times 2 is 4. So we have 8 equals 4 plus c. Therefore, c equals negative 4. I'm sorry, positive 4. So y is 2 x to the 1/2 plus 4, or equivalently 2 square root of x plus 4. Either one of those is fine. Okay? Questions? Questions, comment, complaints, letters of recommendation? Nothing? Okay. B to I. Arlene, why were you so late?
I'm sorry.
Okay, what was the reason?
I don't have an excuse. I fell back asleep and my alarm didn't go off.
Man, I'm concerned about the future of this country as well. I'm just
Me
kidding.
too.
You too? Well, you should be. All right, so let's do this one. Or 1 over x squared, and it passes to 1,3, right? So same as before. Separate the variables. dy is equal to 1 over x squared dx. Integrate or find the antiderivative. The antiderivative of dy is y. And then we're going to do this one, 1 over x squared dx, right? So let's think of this as x to a power, right? So this piece is going to be y equals the integral of x to the -2 dx. And we're going to use the power rule, what we just learned. We're going to use that, okay? So this is going to be equal to what? We add 1 to the exponent, -1, and we divide by that new exponent. So this actually becomes -1 over x plus c, right? And now we use the condition, 1,3. So when y is 3, x is 1, -1 over 1 plus c. So c is actually 4. So the equation of this curve is -1 over x plus 4. Okay? Questions? So before we move on to the next example, how would you try to do this one? Tell me, somebody.
Well, it would be,
Say that again, Gao.
can you hear me?
Yes, I can hear you now.
Okay. Okay, good. So it'd be x to the -1, and then with the power rule, it'd be x, so it'd just be x, I don't know, -1 plus 1, that'd be x to 0, which is strange. And then
Divided by
0.
Can we do that?
Probably not, no.
No. So this actually is an exception to the rule. What's the derivative of 1 over x?
ln x.
ln of x, right? The antiderivative of this is ln, which means that this is true with the exception when n is equal to -1. N has to be different than -1, okay? So the power rule does not apply when n is -1. So that's why is this. Now look, what is the domain of ln of x?
Is greater than 0.
I'm sorry, Julie, what did you say?
X greater than 0.
X greater than 0, positive numbers, right? So look, since here we don't know what these x values are taking, we don't know if they're positive or negative, okay? So the actual antiderivative is ln of the absolute value of x plus c. If we know that x is positive, then it's just ln of x. But if we don't know what x is, then it's the ln of the absolute value of x, okay? Keep that in mind as we find antiderivatives of ln, okay? All right, so that's 1. B, right? Yes.
The plus C, like the on the last, like
Uh-huh.
where did you get the plus C?
Okay, the plus C is because what's the derivative of a constant?
Like just 0?
Uh-huh, the derivative of a constant is 0. So if you take, if this were ln of the absolute value of x plus 5, what would be the derivative of this?
Oh, like 5 would just be plus 0, like 1
Right,
over X.
so the derivative of this is still 1 over x,
Yeah.
right?
Yeah.
If instead of 5 you have 10,
No,
the
yeah.
derivative of that is still 1 over x. Make
Mhm.
sense?
Yeah.
So that C is a constant of integration because it could be actually plus any constant, okay?
Okay. Okay.
And then the condition that they give us allow us to find a specific value for C.
Yeah.
So
Okay.
this makes this solution unique, okay? If we
Yeah.
don't have a condition, then this plus C should be any value of C, any
Okay.
constant. Make sense?
Yes. Thank
Awesome. All right. Can I have hot chocolate then?
you.
No? Okay. All right, so let's do D. 1D, I, okay? It says that we have dy dx equals x plus 1 over x, right? And the initial condition, or the condition, no initial condition, the condition is x equals e, y equals e, right? The question is the same. Find the equation of the original curve, right? Basically solve this differential equation. So we start as we did before. Separate the variables. dy equals x plus 1 over x dx. Once we separate them, we integrate, right? The antiderivative of dy is just y. And this, that's what we're gonna play with it. All right, so strategy, hint. If possible, you want to simplify before you try to find the antiderivative, okay? So that's what I'm gonna do, simplify before taking the antiderivative, all right? Iman, stop testing, pay attention. All right, so that means that I'm going to split this up this way, integral of x over x plus 1 over x dx, because x is a common denominator. Make sense? Tambi, does it make sense? Yes? Awesome. All right. Julie, are you with me still? Julia Bechara? Yes?
Yes.
Okay, just wondering. All right, so we're simplifying, correct? Well, this is x over x, that's just 1. So this is 1 plus 1 over x dx. And in order to solve this, I'm going to split this up into 2 integrals, okay, as we did before. So this is just the integral of 1 dx plus the integral of 1 over x dx. All right. Now, what's the antiderivative of 1?
X.
X. Plus, we just learned that this, the antiderivative of this is what?
ln of x.
Ln absolute value of x, because we don't know if that x is a positive or a negative, okay? So that is my function so far. So y up to this point is x plus ln of the absolute value of x plus c. Now we're going to use the condition to find that value of c. So that means that y is e and x is also e. The absolute value of e is e, so that's why I didn't put the absolute value of this plus c. How much is the absolute value of I'm sorry, what is the ln of e? 1, right? What happened with these two e's?
Cancel out.
They got the coronavirus and they went away. Right? So C is -1. Right? So Y, x plus ln absolute value of x minus 1. So this is my final answer. Final answer? Yes, final answer. All right. So what did we learn? Simplify before taking the antiderivative, okay? When possible, simplify, then you take the antiderivative. All right, so d2i, okay? It says dy dx is 1 over 2x, okay? Really quick, dy is equal to 1 over 2x dx. Anti-differentiate on both sides, so you get y equals, so notice what I'm going to do. 1 over 2 is still a constant. So I'm going to take that outside the integral and I get that. Does it make sense? So I simplify, basically. Put the constant outside. Well, that's going to be y equals 1/2 ln absolute value of x plus c. And then now you just use the condition to do it. The condition is e squared comma 5. Okay. So 5 equals 1/2 ln of e squared plus c. Ln of e squared is 2. 2 times 1/2, 1. So c is 4. So my final answer here is y equals 1/2 ln absolute value of x plus 4. I have 3 minutes to do one more. So I'm gonna do problem 3, okay? Problem number 3. It says the gradient of a curve is found by this, dy dx equals x squared minus 4. Part A says, find the x coordinate of the maximum point, justify that it's a maximum. So how do we find maximums and minimums? We take the derivative, which is given, set it to 0, find those values, and those are the possible maximums and minimums because those are the critical numbers. So then we take the derivative, we make that 0, we solve for x is gonna be either plus or minus 2. So one of these is a max, okay? So I'm gonna use the first derivative test. I'm going to make a sign chart of the derivative. According to this, that derivative is 0 at -2 and up to, right? This sign chart is for the derivative. If you look at the derivative, that's a parabola. It's a parabola that opens up. So that parabola is doing this because those are the zeros. So what does it mean? It means that before -2, that is positive, is above the x-axis. Between -2 and 2 is negative, and after 2 is positive. So when do we have a maximum? When the derivative changes from what to what?
Negative to positive or negative to positive.
The other one.
Or you said maximum?
Maximum, yes,
Oh,
sir.
then that's positive to negative.
From positive to negative. So at x equals to -2, y has a max because dy dx, the derivative, changes from positive to negative. Okay, so that's where the maximum is at. Part B says find the y coordinate, which means we need to solve this, okay? So y is gonna be the integral of x squared minus 4 dx, right? Separating the variables and integrated on both sides. The antiderivative of x squared, x cubed over 3. The antiderivative of 4 is 4x plus c. And then now we use the condition. What's the condition? It says that the curve passes from 0, 2. So y is equal to 2 when x is 0, right? So if I plug in 0, I get 2. So that means that c is equal to 2 because 0 cubed is 0 divided by 3, 0. 0 times 4 is 0, so c is 2. So the equation then is this. Right? The question asks, find the y coordinate of the maximum, right? So that means that I need to plug in -2 because at -2 is where the maximum is at. So if I plug in -2, I get -8 over 3 plus 8 plus 2. This is 10. 10 is the same as 30/3, right? 30 divided by 3. 30 divided by 3 minus 8 divided by 3 is 22/3, which is 7 1/3, which is what they want us to do. Okay? The